Myself, Dr. Mohan Kumar TP, working as an assistant professor, Department of Commerce in Government First Grade College. Now, I'm going to talk about bivariant analysis. The basic task of most of the research is bivariate analysis. What does that involve? It analyzes the interrelationship of two variables and which also helps to null hypothesis whether the relationship between two variables, if there is no relationship or unrelated, then automatically that hypothesis is going to be rejected. That's called null hypothesis. Is equal to independence. It's nothing but these two variables are unrelated. They are not related. There is no covariance between these two variables. Then two analytical perspectives are, the first one is analysis of differences. The first one is analysis of differences, means select independent variable and dependent variable, and after selecting the variables you need to compare the dependent variable as well as independent variable, and after analyzing the difference between these two variables, you need to analyze the association between these two variables. Covariation, whether the two variables has got an association with covariation, or is there is any correspondence between two variables. Then it also predictability of one variable from the other, whether the two variables, among the two variable, is there is any scope for predictability of one variable with other. Then we also need to understand whether this association has got an agreement between two variables or not. Then measure of association, a general term that refers to a number of bivariate statistical techniques used to measure the strength of relationship between two variables. Then measures of association, a general term that refers to a number of bivariate statistical techniques used to measure the strength of a relationship between two variables. Among the two variables, is there is any strength of the relationship between the two variables? Strong relation, weak relation, or no relation? You need to check that with the help of statistical tool. Then the third one, first we have discussed about bivariate analysis A, B. This is C one. Third one, analytical situations you need to analyze. If both the variables are numerical in nature, then what needs to be done? With the help of these two numerical variables, we can graph their relationship with the help of the scatter plot, and need a statistical measure to index the interrelationship between two numerical variables or quantitative variables we call. This measures of the interrelationship of two numerical variables is called their correlation. Relationships among variables, that is correlation analysis. Second one, bivariate regression analysis. Here, correlation coefficient, a statistical measure of the covariation or association between two variables. Example is the dollar sales associated with advertising, dollar expenditure. Then measure the strength of a linear relationship between two quantitative variable, that is numerical variable. That is, say for example, height and weight. Here in the X and Y axis, we are able to see the picture with the plotted one with the line. The line is going from X axis towards Y. So the line which goes upward, slightly upward, the right side upward, means it is always positive correlation. Say for example, the height of the person, as and when it increases, automatically the weight of the person is going to be increased. There is a positive relationship between the height variable and the weight variable. So higher the height, higher the weight. So since it is a both are increasing, automatically it is considered as positive correlation. The negative correlation. Negative correlation means, say for example, higher the price of the product, lesser the demand. So as in one variable is increases, the other variable it decreases. So there is no positive relation, there is a negative relation. So we call negative correlation. The other one is no correlation. No correlation means there is no relation between two variables. Say for example, education and a person who is becoming sage. It may not be true. So there is no relationship between the variable 1 and variable 2, then automatically we call no correlation. Correlation pattern, with the help of, we have already discussed perfect negative correlation. Perfect negative correlation means lesser the weight, lesser the height. Lesser the height, lesser the weight. So both are in a negative mode. The other one is higher the price, higher the price, higher the quality, or higher the height, higher the weight. So it is positively correlated. This is negative. This is perfectly negative correlation. The slope, the line is going from y-axis towards x-axis. So it is not upward. It is downward line. Then correlation pattern, highly positive correlation, which I have already discussed with example, weight and height. Higher the height, higher the weight. The correlation doesn't mean causation. It means high correlation. But it doesn't mean that there is a cause for it. There is a result in it, or there is a cause and effect relationship. Example, rooster's crow and the rising of the sun. Rooster does not cause the sun to rise. There is no relationship between, see, there is, as it may be, we call it is an incidental. It may be incidental, but it may not be true. Rooster, there is no connection between rooster to crow at the same time sun to rise. So it doesn't mean that there is no rooster, there is no sunrise. No. So it means there is a high correlation, but this is not the cause and effect. There is no cause and effect. Then the third example is teachers' salaries and the consumption of liquor co-vary because they are both influenced by a third variable. The bivariate regression, a measure of linear association that investigates a straight line relationship, and it is useful in forecasting. Say for example, marketing forecasting, we call sales forecasting, HR forecasting, economic forecasting. With the help of two variables, we can predict the future. We can forecast the future with the help of this. And in regression, process for estimating the relationship between a dependent variable, that is outcome variable, that is result variable, and one or more independent variable, that is predictor. Then the purpose of regression is prediction and forecasting. You can predict what is going to happen in future. Forecasting what is going to have the sales with the help of the past data. That is, it is also possible to forecast about the future pricing, future sales. That is possible with the help of regression analysis. Then it also helps to infer the causal relationship between independent and dependent variable. Causal relationship means the cause and effect. As and when you increase the price of the advertising, the sales, it may be increased or not. That can be, what is the reason for the increase in sales? Is it the quality of the product, or is it the advertising expenditure what they have made? What exactly the reason behind the increase the sales? So it infers the causal relationship between independent and dependent variable. Multiple regression. It is an extension of bivariate regression. In univariate analysis, we use we analyze one factor at a time. In bivariate analysis, we use only two factor or two variables. But multiple regression, we use the extension of bivariate regression, means multi-dimensional. When three or more variables are involved at a time, it can be used it with the multiple regression. Simultaneously investigates the effect of two or more variables on a single dependent variable. That is possible with the help of multiple regression. Thank you very much for watching our delivery. Thank you very much once again.